Hi, everyone. Thank you for joining us today to this talk. So the idea is give you a brief summary about OpenTelemetry observability and then do a demo. So the talk is about making your CI/CD pipelines speaking in tongues with OpenTelemetry. So if it works, this. It doesn't. Sorry. Oh, here we are. So I need to be closed. So my name is Martinez. I work at Elastic in the productivity team, which is part of the observability division. And I've been in the open source contributing for a period of time. Here is my colleague.
My name is Fernandez. I also at Elastic, also in the observability team. And also part of the community, Jenkins community, I support maintaining a couple of plugins on Jenkins. So that's me.
Okay, here we are. So I'll give you a brief summary about where we are. So the CI/CD, or continuous integration, continuous delivery, probably is a key foundation in any software development in your area that you probably are familiar with. Sometimes understanding what are the resources that you need for running your build or test, what is the platform changes when you do a deployment, or even the capacity plan. So you need to know how many bare metals, cloud providers, and so on, or VMs that you need, are questions that are hard to answer by default. And the idea is these particular questions is not something that you probably ask yourself, but also ourselves, and that's probably why we are going to talk about this. So the CI/CD large scale is also difficult to understand sometimes because you don't know what things start failing. There is third-party system that you interact with, so it's hard to understand what's going on. Mostly when every single CI vendor uses a different way to present the data, right? So in the end, it's the same idea. You have your binary that you generated previously, you compile, you test, and you deploy. So it's simple, right? But how you present the data is not easy, right? Every vendor does something different. But the ultimate goal is, because the behavior is similar, there are operations to compile, so it's easy to visualize with observability. All the logs that you are receiving from the builds that you run, the deployments you run, and so on, are also something that you can correlate them to know that the operation you run actually represent this particular log with all the information, and also the metrics that are important because it gives you a first glance what's going on, right, with your system. For this, we believe that distributed tracing is a key part for this, even for the CI/CD, because it cannot be just used for when the system is down and you want to recover the system to put it in production and healthy again. So that's the idea, and we're going to talk today. So regarding observability, there are 3 pillars, and I'm going to use an analogy. So you think about metrics. You have let's talk about Jenkins as one of the CI/CD systems we use at Elastic. Knowing how big is the build queue, it could be a metric that you need to understand, right? Because that's affecting your capacity plan. All the build logs that is coming from the run or the different pipelines or freestyle jobs in terms of Jenkins are information that is important, and you want to debug deeply, right? What's going on in your system. And traces, as I mentioned earlier, are the different operations. Like you check out the source code, you run a Maven compile, or you upload an artifact to Google storage or S3 and so on. Those steps are pretty much the information you can understand deeply what's going on in your system. So those are the 3 pillars for observability. And OpenTelemetry is just pretty much an implementation of observability. So it's a kind of tools, SDKs, APIs that they are neutral vendor, so everyone could use that, because the main goal of this is you can choose the best vendor for what is your use case. So you want to use the best vendor for traces, and you think that vendor is better because the speed is better and so on, because you use OpenTelemetry. Then you can easily change from one vendor to another depending on the use cases. So this is just an idea of everything that it runs in your system, your platform, and so on can ship data for these 3 pillars I mentioned earlier: traces, metrics, and logs. There are different vendors that they support OpenTelemetry. Those are some of them. Elastic is the one we work with, Jaeger, Grafana, Honeycomb, and so on. Those are some of them that they natively support OpenTelemetry. So now thinking about the CI/CD ecosystem, how you compile, how you test, what tools you use, all those are potentially things or systems that you can integrate with OpenTelemetry and send data, all the telemetry. So what we did back in the days is build different integrations that send data with OpenTelemetry. Let's talk about the first one, which is in Jenkins. So this is a representation of what we built. So there's a plugin for Jenkins. You work out of the box. You configure what is the entry point of the OpenTelemetry that you would like to send data. So all the logs, metrics, and traces are sent implicitly, so you don't need to do anything. So what we're trying to represent here on the right hand is just a trace. So the job that run is in green. That's the entire life cycle of the build. And then every single blue row that you see there represent an operation, a step, quite narrow. On the left hand, you see the pipeline implementation. It worked for traditional jobs, such as freestyle jobs, if you're familiar with Jenkins, pipelines, or matrix jobs, and so on and so forth. Other integration we made, it was a Maven extension. So Maven is the build system for Java. It's a well-known opinionated system, and it works based on goals, and every goal can be a meta goal that run other subset of goals. So the same view that you have for the Maven package, that pretty much is compile, test, and generate a binary. So it's represented as a blue spans there, which are pretty much that particular minimal goal that run, like compile took 154 milliseconds, and so on and so forth. So that's the extension we made as well. Regarding OpenTelemetry, other integrations, we made Ansible integration as well, and something more for testing. But I don't want to talk more because tomorrow here at 2 p.m. there's another talk about OpenTelemetry and test, and that will give you a vision on how you all together test data could be collected from OpenTelemetry. I don't want to talk more. So you can jump in this tomorrow. So now it's time for the demo. I roughly touch a little bit of the three concepts of OpenTelemetry and observability. So our main goal is with the demo is Canary deployment, quite opinionated, simple for the demo. So if it works, bear with us. If not, we'll do our best. So it's Dockerized. It's going to run in our machine. It's a Spring Java application, pretty much a hello world, and that's what we are going to iterate with. It sends data with OpenTelemetry because there is an agent OpenTelemetry for that particular Spring Java application, and it sends data to the OpenTelemetry collector. Similar with Jenkins, there is a plugin configured to send all the traces metrics for Maven as well, as I mentioned earlier, and then Ansible to deploy the service in a new version in a new system, and PyTest to run some kind of health check. So we want to validate if the service that has been deployed is good to be promoted. So this is the idea of traces and logs and metrics that we send. Jenkins will send everything, log, metrics, and traces. Maven will run afterwards. And there is always a context propagation. So Jenkins run a Maven build. So we will be able to see the two traces together. And it will help us to understand holistically how all this CI/CD workflow works. Similar with the other tools. So for us, the Canary deployment, I mentioned, quite opinionated. So it's just trying to illustrate how all together work. But the idea is we push changes, that we made some changes in the source code, and eventually a Jenkins build will run. And if it compiles, then it will deploy. And if the Canary service is good, because there is not any errors in the transaction, so like accessing to the entry point, no errors, then we'll be able to deploy the version to the other services, the same version. What are the different use cases? We're trying to do 4. Chain hello world by byword in the UI. Then a sneak dependency. A sneak is a security layout we run for Maven to validate that dependency don't have any security impact, like denial of service and so on. The other one is we're going to synthetically introduce an error in the application, how the rollback work, and a password leak, like probably everyone is familiar with. We are not going to present much with Jenkins UI. We are going to focus more in the traces metrics in the OpenTelemetry area. And I'm going to pass the talk to.
As Victor said, we have a Jenkins running. We have a Nexus for the artifacts. The 2 applications, that is a simple application that only show a message in a browser, and a Jenkins that will trigger all the builds. So let's start with him. So we will receive some notification on Slack to know that there are changes. So we will start with making change in our code. We have prepared some patches to make things agile and don't spend more time in Git. So Git apply demo, the first change. We check the change. So in the first change, we only change the message of the application and the version. We change to the version 2, and we change a message to say bye instead of hello. That's it, nothing else. So we commit the change, -m, feature, say bye. Okay, that's fine. We push the change, push. So we have pushed the change to the Git repository, and that trigger a build. We have to change recently the post hook because we have problems with the checkout, but it's fine. So here we have the Kibana instance that is collecting all the data related with OpenTelemetry. And at some point, we saw that there is a Slack notification that the build has finished. So if we go to the Slack notification, we can go to the traces directly. And we show you how the pipeline has failed, because it says that fails. So here we have the transaction. And if we go to the transaction, we see that there is traces from Jenkins and Maven. The Jenkins traces are in blue. The Maven traces are in green. The other side. Jenkins in green, Maven in blue. We see the whole pipeline and the duration of the pipeline, and there is some errors. We check the errors here. This one is not. It's not. It should be this one. No. Don't want to show the error. No one. So let's go down. So we saw the build. We see the start phase, the agent provisioning. Here we saw the checkout of the Jenkins. Here we see that is triggering the Maven goal to build the Spring application. And then we made some stuff, tests. Here we see the test. And now we see here the sync test that has failed. If we check the logs, here, we will see exactly what is the fail in the sneak thing. So we see that the sneak failed, and if we go up, we see that there is a Daniel Server error in one of the dependencies that we have in this application. So let's fix the thing. We have a patch for that. Git, apply, demo, the second change, git diff. And we fix the issue based in the specifications that Sneak say to us, that is bumping the dependencies. We bump the dependency of Spring Boot and another dependency of Spring that resolve the Daniel Service error that was in the code. So we do again a commit, that is a fix. Security issue. Fine, we make the push, and we make the post hook to trigger the build. So we push all the changes, and we trigger another build. In the meantime, because this build will take a little bit longer, we see some stuff we show some stuff in the Kibana side. So here, we see the three services that we have right now. The antivirus is the application, the Jenkins and Maven, that is the traces from the build. So let's go to the antivirus application. In the antivirus application, if we see the latency, the request that has, we have a job that is continually creating traffic for the application to see traces here. We see that we have only one endpoint that is receiving traffic. We see that we have two instances. There is no errors. We don't see any error in the transaction rate. So Yeah, we can show more stuff here. Services, if we go to let's see the Maven service, meantime, that we see the build goal that we have. And here we see the same. We see some traffic input and the traces from the Maven build. We see the main goal and the goals that we have, HTTP requests, so on and so forth, sneak test. We can click, for example, in the main transaction, and we show some information related with the Maven goal and the OpenTelemetry data that we have, events, and so on and so forth. It's taking some long. Let's check Jenkins. It's there. Okay. So the build finish and say that's success. Let's check the traces to see how it looks. So here we have the deploy that we say that is a Canary deployment. We see the traces that we have in this build. Let's go to the view of field trace, because this is only the deployment, because we call a Jenkins job from a Jenkins job, and distributed trace and give out the latest part. So this is the world pipeline. We have the demo world pipeline that is running in Jenkins because it's in green. We have in blue Maven, Ansible, and the Canary deployment that is in purple. We see the checkout, the build agent provisioning. Then we see here the Maven stuff. The Maven stuff, building the binary, testing the binary. We continue in Maven, build the Docker image. We deploy the Docker image in the Nexus repository. Yeah, anti-fraud, dependency tree, wherever, blah, 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 dependency. Then we arrive to the deploy part. That is another job in Jenkins. So in the distributed tracing, we show that all the traces, that all the parts of the build that we are triggering has many pieces. It has 2 jobs in Jenkins, and the Maven part, the Ansible part, and everything. If you see, there is a hierarchy of the spans in the way that they are running. So this is the build job. That at some point here we see that call Ansible and run the deploy Canary playbook that we have in Ansible, and we show the tasks from Ansible, the FATs, the load, the Docker Hub, wherever, the health check. That is the test that we have in Python that run with ptest and make a check in the stack that the error rate in the last 5 minutes doesn't pass a threshold. If they pass the threshold, we make the rollback. In this case, there is no errors because the application don't return an error. So what we make is pass to the next stage, that is make the full deployment again with Ansible. We run another playbook that's deploying the 2 instances that we have, deploy the 0.02 version. So if we go now to the 2 instances that we have, now instead of hello world, they say bye world. That's it, simple, nothing special. So let's move to the next stage of the demo. That is, now we want to apply the third part. We see the change. And what we were doing now is we modify the application to fail otherwise. So every time that we will check the health check endpoint, the application will fail because it's the version 3. That's it, simple. We push again. It's not fish, it's a shore. Error. Okay. We push the chains. We trigger the post hook. And this will make the chains, trigger another job, and so on and so forth. In the meantime, let's go back to Kibana and let's see what we have right now. Because we are running more services in the last build, we see more services here. Is failing? No, this is another thing. Okay, we see more services here. We see the ones that we had before, anti-fraud, Jenkins, and Maven, and we have a couple more. The Ansible one and the PyTest one. The Ansible one, we can show how it looks the execution of a playbook. If we go, for example, for the full deployment, that probably is bigger. We see how a playbook looks like a transaction. We see the playbook and all the tasks that are in the playbook. We can check the metadata, for example, of the main playbook, and we saw some information related with the playbook, the IP, the name, the user that launched it in, the session, whatever. For PyTest, we have more or less the same thing. We have the PyTest service, and we go to the test suite, and then we show the test suite as an span, as a transaction, and every test appears as an span. So we can check the metadata of one of the tests, and we see the test name and the status is pass or fail. So we have really a bunch of information related with all the processes that we are running in Jenkins that are not related with Jenkins, really, because there are things that run in Python, run in Ansible, run wherever you have an agent that sends data to OpenTelemetry. What we can show also is the relation that all services has. If we go to the service map, we can show all the services and how are they related between each other. Because all that information is in OpenTelemetry. So we have Jenkins that interacts with Ansible and interact with Maven. Maven interact with Docker Hub. We interact with our Nexus repository and also with Sneak and also with GitHub. And then we have the two applications and defraud that don't interact with anything. And the Canary that doesn't show, in PyTest doesn't have that implication. Okay, that's. I don't know if we can make the wall demo, but it's fine. So we have the next theme, version 3, is that one? Is there? Yeah. So we go to the build that should fail, and we check what is failed. This is the change that we remember that is the change that we made to make a synthetic error and see the rollback. So again, we have, I have to hurry because if not, we don't arrive. We have the same thing, Jenkins, deploy Canary, and then when we arrive to deploy to the test that we have in Python to check the error rate, which the error rate is not the correct one, and we make the rollback at some point. The proof of deployment, yeah. Is in the wall pipeline. It's not in that one. So here, if we show the wall pipeline, we see the rollback playbook that is running here. So if we check why this failure, we see that if we go to the anti-fraud services and we check all the traces that we have until now, we will see that at the beginning we deployed the version 1 at some point. This is from the, yeah, we deployed the version 2. The version 1 is before that time. Let's say relative, 30 minutes. Let's say 20 minutes, more or less. Yeah. I don't find the version 1. Okay, but this is the deployments that we have. That's version 2, and now in the latest execution that we try to do, we try to execute the version 3, but we make the rollback, and now we have the version 2 again. If we see the traces, we see that then in the health checking points, we have an error rate of 23%. That is the root cause of what we make the rollback. And everything is in OpenTelemetry. We are doing everything in OpenTelemetry. We see the errors that we have, and we see 503 errors in the services that we have, in both. So something is really wrong. Yeah, and we don't have time for the leak because yeah, it's short. So let's move to the next thing.
Right. So for the future, every single span you saw there will contain metadata. It depends what information you gather is something like you probably want to standardize. So how you use Maven, how you use Jenkins, GitHub, anything like send data for the CI/CD. So that's important to mention, like we need to standardize. Like every vendor that you use should provide probably the same kind of naming and attributes. So that's something we are gonna start working on, and there is this, actually in the CD, there is a SIG events about actually standardize this. We want to encourage people to add more integrations with OpenTelemetry, like Gradle, I don't know, any other build system that you would like to. It could be also sending data. We are planning to support correlate logs, so for Maven, so rather than sending traces, also correlate what is the build output log to be able to actually, debug if something is wrong. And finally, all the machine learning, right? So we want to start thinking about how we can make this easy to, digest data that is massive, to discover patterns like probably it's hard to discover unless you are a specialist. If you want to know more, these are some of the references that you can, read more. Thank you. And I don't know if we have time for some questions, like 2 minutes or 3 minutes. Oh, okay. So we went in a rush. We couldn't show you the password leak. So it's just pretty much discovering regex for all the logs that are coming from OpenTelemetry. I give you just that present. You didn't see that, but that's it. Any questions or anything that you like us?
If I happen to use Maven and Jenkins, how much effort is it to replicate the demo?
The demo, right. This particular integration with Jenkins is open source. It's under the Elastic GitHub organization, and there is a demo folder there that actually simulates some of these. So it works pretty much Dockerized, and you can easily interact with. So my recommendation, you want to start with, first, the OpenTelemetry collector might help you because it's the place where you send data, and automatically you can configure with some YAML what is the vendor. You can use Elastic specifically, you can use Jaeger, you can use Prometheus, and so on. So you can specialize where. So having that particular OpenTelemetry collector close to where the data is coming from, obviously, because you want to reduce latency and so on, is simple. And then the other thing it will be related to Jenkins plugin. It's a global settings. If you are familiar with Jenkins, it's pretty much fill in the form what is the password, user, the OpenTelemetry entry point, and then it will start working. For Maven, you use pretty much environment variables that we try to standardize for everyone, like the OpenTelemetry, I think they use header, OpenTelemetry, I don't remember now. It's a HTTP header, but it's pretty much 2 environment variables that you define entry point, password, and then it will start working on. So you just need to change the POM file with the extension, and then the magic happens. So it's trying to instrument implicitly rather than explicitly. So it should work out of the box.
In all the tools that we made, plugins and callback and so on, in the repository you have a demo for all them. And it's something that is Dockerized that you can run and you can see how it works in a simple way.
Right. Please.
About machine learning, so how is it, I suppose there were already machine learning within Elastic. Do you need that?
Right. That's a question, obviously. So the question is about the machine learning. So in this case, as we work at Elastic, we can use the machine learning because it's one of the features, capabilities we could use. But again, is it already integrated because all the data is in Elasticsearch? Then the machine learning is a node that you specialize to do make analysis of the data. Probably other vendors might have something similar, or the good thing is OpenTelemetry data you send with this collector idea, you can analyze and create your own tooling as well, because you ship data to the backend that you want, and then you can specialize your system. So you can build your own machine learning with Python or any other tool.
Yeah, you are not limited to one backend. So if you want to send data to more than one backend, Elastic, Honeycomb, whatever, you can, because OpenTelemetry allows you to have more than one backend. So you have, as said before, you can choose the vendor, and you can choose the best vendor for the problem that you want to resolve.
Right. Any other question? Okay. So we're going to be around here, so feel free to poke us. And thank you, everyone. I appreciate your time that you stay here. Thank you.